Hey there, class. Mr. Posky here. Hope you're having a good day so far. We're going to go ahead and go over the 3.6 homework because this is a very hard lesson and there's a lot of moving parts. And I actually, when I was making the key for this, I made a couple mistakes and it messed up the whole thing. So I'm guessing you guys probably may have some of the same things going on. So we're going to go through this all together, see how we do, and hopefully this will make more sense by the end of this video. So number one. It says, decide if the given ordered triple is a solution of the system. So when we're trying to determine if something is a solution, we should be able to plug it in for x, y, and z and see if it's going to be a solution or not, if it's going to be true or not at the end. So we're going to call it, we have 1, 4, and 2 we're checking, so we're going to go x, y, and z. That's bad z. And a little better z, but okay. So we're going to plug in each of these equations. I'm going to use red for this first equation, all right? So we have negative 2x minus y plus 5z equals 12. We have 3x plus 2y minus 7z equals negative 7. And negative 5x plus 4y plus 2z equals negative 17 for all our problems here. So we should be able, if we plug in 1, 4, and 2 to each of these equations for x, y, and z, they should all be true. And once you get one that doesn't work, you can stop there. But even if we do get one that's not going to work, we're going to check all of them just to make sure we feel good about plugging into all the equations, okay? So we have negative 2x minus y plus 5z equals 12. So I'm going to plug in, we're going to plug in 1 in for x. I'm going to do negative 2 times 1 minus y, which is 4, plus 5 times z, which is 2, equals 12. All right, now we just got to simplify. What's negative 2 times 1? That is negative 2 minus 4 plus 5 times 2 is 10, equals 12. Now, do we do 4 plus 10 or we do negative 2 minus 4? This is PEMDAS stuff, order of operations. We're actually going to work left to right because subtraction and addition are equal rank in PEMDAS. We have to work left to right. They're equal, yeah, they're basically the same rank, just like multiplication and division. So we're not going to do 4 plus 10 first because even though addition comes first in PEMDAS, we're going to do negative 2 minus 4 first. Just a quick reminder with our order of operations. So negative 2 minus 4 is negative 6 plus 10 equals 12. What is negative 6 plus 10? That is 4 equals 12. Does 4 equal 12? It does not. So this is going to be not a solution for this one. So we could actually stop there, and we would if we were actually doing this problem like on our test or whatever, but we're going to keep going from now on. Just going back to the last thing I said here too. So when you have subtraction and addition, they're both in the same problem, you got to go left to right. So if we go left to right, you can see that subtraction comes before addition from left to right, okay? Same thing with multiplication and division. So if we had 10 divided by 2 times 4, division and multiplication are equal ranks, so going left to right, we would do 10 divided by 2 first, which is 5 times 4, and then we do 5 times 4, which is 10. We would not do 10 divided by 8, okay? Just keep that in mind. All right, let's move on here. So we're going to use, we did red. Let's go ahead and use green for the second equation. So we have 3x plus 2y minus 7z equals negative 7. So we're going to plug in 1 in for x, so 3 times 1, plus 2 times y is 4, minus 7 times z, which is 2, equals negative 7. And this is actually extra work right now I'm doing. Like I said, we don't have to go on and check more of these, but we're just going to just get the practice. So 3 times 1 is what? That is 3. 2 times 4 is 8. Negative 7 times 2 is negative 14. All right. Now scanning left to right, we do 3 plus 8, which is 11, minus 14, which equals negative 7. 11 minus 14 is negative 3. Does negative 3 equal negative 7? It does not. This is not a solution for the second one. We're at 0 for 2 right now, so not a good start for this equation, but we'll keep going. So now we have negative 5x plus 4y plus 2z equals negative 17, so we're going to plug in 1 for x, so negative 5 times 1, plus 4 times 4, which is y, plus 2 times z, which is 2, equals negative 17. All right, negative 5 times 1 is negative 5, plus 4 times 4 is 16, plus 2 times 2 is 4, equals negative 17. All right, then we have negative 5 plus 16 is going to be 11. 16 minus 5 is 11, plus 4 equals negative 17. What's 11 plus 4? That is 15. 15 does not equal negative 17. So this one's not a solution for this one either. So it's not a solution for any three of them, so we're actually going to be our final answer. I'm going to actually move this x up a little bit so we can get the room for the next problem. So this one's going to be, what we're going to write is not a solution. All right, it needs to be true for all three of them. It's true for none of them, so that means it's not a solution. All right, so now we have three more problems that are going to be the hard ones, all right? So 2, 3, and 4, we're actually doing solving systems, and we're going to use elimination. It is possible to use substitution to solve these, but that makes it a lot harder than it should be. So when we're doing these problems, just know we're probably going to use elimination. We're going to use elimination a few times during the problem. We're going to use it for, like, to get rid of one equation, get rid of one variable, then the second variable, and then we'll be able to solve for the last variable. So the trick to doing this, you want to look at all the variables and see if there are any opposites, first of all, that will cancel out nicely. So between the x's, none of those are opposites. Between y, 2y, and 3y, none of those are opposites. And 6x, 6z, 5z, and 4z are not opposites. So if you had something like, I don't know, if you had like, it's just like, trying to explain it a little bit better. If you had, let me see the problem that I had here that was a good example. So like if we had, for example, we had 3x, negative 3x, and 3x, and we could just cancel, we could use the middle equation to cancel the x in the top equation and use the middle equation to cancel the x in the bottom equation. But we don't really have that here. So the other thing you want to look for is you want to look for a single variable like a 1y or a negative 1y or a 1z, negative 1z, anything like that. Do you guys see a 1y or a 1z or 1x anywhere? Yeah, I see this positive y right here. So we're going to use that equation to cancel variables in the other two equations, because we can multiply 1y by any number we want, and we can multiply it really easily to get the opposite of the numbers here. So I'm going to use the top equation because that has the 1y to cancel variables in the other two equations. So we're going to do these two top equations first. Okay, so we're going to use the top equation as our frame of reference to eliminate a variable from two of the other equations. So I'm going to write the top equation. So we have negative 2x plus y plus 6z equals 1. And we have 3x plus 2y plus 5z equals 16. Okay, so now I want to cancel, because I have that 1y there, I'm probably going to want to cancel the y's because it's going to be easy to do that. So what can I multiply the top equation by to get the opposite of 2y? I can multiply by negative 2, can't I? Yeah, that's going to work. So now we can multiply that that negative 2 by everything in the top equation. So we're going to get negative 2 times negative 2x is 4x. Negative 2 times y is negative 2y. Negative 2 times 6z is negative 12z. And that equals negative 2 times 1 is negative 2. And then write the bottom equation the way it was. I'm going to be cross-referencing my work. I actually filled out the worksheet before I did this video to make sure I did everything right here, because it's kind of tricky stuff. This is hard. Okay, so now let me just double-check. Got everything written down correctly. Okay, so now we're going to add straight down, because the negative 2y plus 2y, those are going to cancel. They're going to eliminate. 3x plus 4x is 7x. Negative 12z plus 5z is, negative 7z. Then we got negative 2 plus 16 is 14. So you can see we eliminated the y's. We eliminated one of the variables, which gets us one step closer to being able to solve this. All right, the trick to elimination is to actually eliminate all the variables, so you're down with the one variable so you can solve. Okay, so now we did the top two equations. Now we're going to use the first equation and the bottom equation because we want to cancel the y's in that equation too, so we can compare them. So we have negative 2x plus y plus 6z equals 1, and we have 7x plus 3y minus 4z equals 11. Okay, so again, we're using the top equation to cancel stuff in the other equation. We're trying to cancel the y's. If we cancel the y's in this one, we also want to cancel y's in the second one. It's not going to help us to do other variables, so we want to stick to the same variable to cancel here. So I had that 1y right there in the middle. What's the opposite of 3y going to be? It's negative 3y, so I can multiply the top by negative 3, so that we get negative 3y, and that's going to cancel. So we have negative 3 times 2, negative 2x is 6x. Negative 3 times y is negative 3y. Negative 3 times 6z is negative 18z. And negative 3 times 1 is negative 3. Double check my work. Looks good. Then we're going to write the bottom equation the way it was. 7x plus 3y minus 4z equals 11. Now all we got to do is add straight down because the y's are going to cancel. So 6z plus 7z is 13x. Negative 18z plus minus 4z is negative 22z. And then negative 3 plus 11 is 8. Okay. So now we have, we eliminated the y's. Now we need to eliminate one more variable. So what we're going to do is we're going to take these new equations and we're going to eliminate one more variable. We're going to do elimination again. So we have right at the top of two equations the way they are, 7x minus 7z equals 14, and we have 13x minus 22z equals 8. So for this one, it's a little tricky because we don't have a 1x or 1z to work with here. We're going to have to multiply to get opposites. And so when it's kind of hard to figure out multiples of 7 and 13 that are going to end up being the same, so like we go 7, 14, 21, try to find a number that divides by both 13 and 7. A shortcut to fix that, instead of like just listing out all the multiples or just multiplying into infinity, is just to multiply by the opposite number. So I'm going to multiply the 7x by 13 and the 13 by 7. So we're going to multiply that. So we're going to multiply the top. I'm going to multiply by, these are both positive too. So I'm going to multiply the top by negative 13. Let's add 3. And the bottom by 7. So that's a shortcut if you don't want to figure out the exact least common multiple. All right. So negative 13 times 7x is negative 91x. Negative 13 times negative 7z is positive 91z. Equals negative 13 times 14 is negative 182. Got that on my sheet here. I didn't do that mental math in my head. Then we got on the bottom 7 times 13x is 91x. 7 times negative 22 is negative 154z. And we got 7 times 8 is 56. Okay. So you guys can see all that. Pause the video if you need to. All right, now we can add straight down. And the x's are going to cancel because negative 91x plus 91x is 0. Negative 91z minus 154z is negative 63z. And that equals negative 126. When you add negative 182 plus 56, divide by negative 63. We're going to get z equals, that's going to be what, 2? It's going to equal 2. So we got one of our variables here. That's awesome. Now I got to keep cruising along. So we got z equals 2. So now I need to take this 2. I need to plug it into either this equation or this equation to figure out what x or x is going to be equal to. So I'm going to plug into, which one did I plug into? I plugged into this one right here, the 7x minus 7z. So we're going to do 7x minus 7z equals 14. We're going to plug in this 2 in for z because z equals 2. So we have 7x minus 7, oops, that's bad, 7 times 2 equals 14. 7x minus 14 equals 14. When you multiply 7 times 2, add 14. 7x equals 14 plus 14 is 28. Divide by 7. And we get x is going to be equal to, 28 divided by 7 is 4. Almost done. Now we got z and x. What variables left? We got to find y. So we're going to find y now. So I'm going to plug into, which equation did I plug into? I picked the middle equation in this over here. So that would be the easiest one to plug into. So we have 3x plus 2y plus 5z. I like all positives. It's very nice. Equals 16. So we're going to plug in what we know. So we know x is 4. So we're going to do 3 times 4 plus 2 times y, which was negative 3. Do we know y? Wait, look at the right problem here. We don't know y. We're looking for y. We know z, sorry. Plus 5 times z, which was 2, equals 16. 3 times 4 is 12, plus 2y plus 5 times 2 is 10, equals 16. 12 plus 10 is 22, plus 2y equals 16. Solve for y by subtracting 22. 2y equals 16 minus 22 is negative 6. Divide by 2. we get y is equal to negative 3. So our final answer, we got x, y, and z now. Our final answer is going to be the ordered triple 4, negative 3, and 2, x, y, and z. All right, so let's review what we did there. So we found a variable we wanted to cancel, and we used that same equation to cancel a variable in the second and third equation. So we use this plus y right here to cancel y in the middle equation and the bottom equation. And then when we got those two new equations, we took those, we did elimination again, and we did elimination again to cancel the x's. And then we got what z is equal to. Then we took whatever we got z is equal to, and then we started working our way back to the beginning, to the original equations. We took this 2, we plugged it into one of these two equations that we found. And then after we found what x was equal to, then we plugged into the original equation, which was either of these three right here. So, yeah, it's a lot of work. Like I said, I made a couple of mistakes when I was doing this, so feel free to ask questions during class and keep focused here. We've got 2 more problems to do, and hopefully this will make more sense as we go. All right, number 3, solve the following system. We have x minus 6y minus 2z equals negative 8, negative x plus 5y plus 3z equals 2, 3x minus 2y minus 4z equals 18. So for this one, do you think we should cancel the x's, the y's, or the z's? Well, let's look at this. The x's, we have x and negative x, which are going to cancel nicely already. So I'm probably going to might use x's for this. It's looking good already. We'll keep checking, but then we have negative x and 3x. I can just multiply the middle equation by 3 to get them to cancel. These ones have all different numbers, probably not so easy to cancel them nicely. These ones have all different numbers, probably not so easy to cancel them very nicely. So what I'm probably going to do is I'm going to use the middle equation because that's a negative x. I can multiply that easily to cancel the top equation and the bottom equation x's. So we're going to use this middle equation to compare the two. So we're going to do the first two equations first. So we have x minus 6y minus 2z equals negative 8, and we have negative x plus 5y plus 3z equals 2. All right, so nice thing about this, when you have opposites, you have positive x and negative x, those are going to cancel right away. No work needed to multiply. These are going to cancel right away, which is excellent. Then we have negative 6y plus 5y is going to be negative y. Negative 2z plus 3z is going to be just positive z. And then negative 8 plus 2 is negative 6. All right, now we need to use the middle equation to cancel the x's. We canceled x's, we got to cancel x's again. We got to keep going and continue all the way through. So let's go ahead and write that down. We have negative x plus 5y plus 3z equals 2, and we have 3x minus 2y minus 4z equals 18. All right, I want to cancel the x's again. What can I multiply the top equation? We're going to use that middle equation again. What can I multiply this top equation by to get the opposite of 3x? Well, the opposite of 3x is negative 3x, so I can multiply the negative x by 3 to get the opposite of 3x, which is negative 3x, all right? So now we're going to rewrite that again. 3 times negative x is negative 3x. 3 times 5y is 15y. 3 times 3z is 9z. And 3 times 2 is 6. Then write the bottom equation the way it is. Now we're going to add straight down. X's are going to cancel like we wanted to. I can keep going all the way through. 15y minus 2y is 13y. 9z minus 4z is 5z. And 6 plus 18 is 24. All right, now we have 2 new equations where the x's are gone. We're one step closer to our end where we need to get one variable. So we're going to take these 2 equations now, and we're going to go ahead and we're going to solve and try to cancel a new variable. So I have negative y plus z equals negative 6, and I have 13y plus 5z equals 24. I'm going to add straight down. Actually, no, I'm not going to add straight down. My mistake. So we need to multiply to cancel either the y's or the x's. So we can multiply the top one. The opposite of 13y would be negative 13y. I can multiply the top one by 13 to cancel it out. Or I have 1z and positive 5z. I can multiply the top by negative 5 to get the opposite. I'm going to multiply the top by negative 5 for this one. But you could also cancel the y's if you wanted to and continue that way and just solve for z. But I'm going to cancel the z's and solve for y. So negative 5 times negative y is going to be 5y. Negative 5 times z is negative 5z. Negative 5 times negative 6 is 30. Then we have 13y plus 5z equals 24. There's lots of ways to approach this one, so don't be stuck with the way that I'm doing it. If it makes the most sense to you, that's cool, but you can cancel whatever variables you want. So now we're going to add straight down. The 5z's are going to cancel. 5y plus 13y is 18y. 30 plus 24 is 54. Divide by 18 to solve for y. We're going to get y is equal to 3. Y is equal to 3. Okay. So now what do? We got y is equal to 3. Well, now we need to work our way backwards a little bit, and we need to solve for, plug it into one of these middle equations that has just y and z so we can solve for z. I'm going to plug into the bottom one. I'm going to plug into 13y plus 5z equals 24. I'm going to plug in 3 in for y, so 13 times 3 plus 5z equals 24. All right. 13 times 3 is 39, plus 5z equals 24. Subtract 39 to get 5z by itself. 5z equals negative 15. When you subtract 24 minus 39, divide by 5, and z is going to be equal to negative 3. Are we done? We got y and z. What else do we need? We also need x. You can pause the video here if you need to catch up a little bit. We're almost done though. We're just going to plug into one of the other equations to solve for x now. Okay, we're going to plug into I'm going to pick the top equation because it's a 1x minus 6y minus 2z equals negative 8, which is really nice. We're going to plug into x minus 6y minus 2z equals negative 8. So I'm going to plug in x we don't know. So x minus 6 times y, which is 3. Minus 2 times z, which is negative 3, equals negative 8. So x, negative 6 times 3 is negative 18. Negative 2 times negative 3 is positive 6, equals negative 8. Negative 18 plus 6 is negative 12, equals negative 8. Add 12 to both sides. X is going to be equal to 4. So what's our final answer? We got x, y, and z. Our final answer is going to be x, which is 4, y, which is 3, and z, which is negative 3. And that is our final answer. A lot of work for one problem, huh? This is like, you guys are getting up to like calculus level stuff here pretty soon. This is pretty tricky. All right, one last example. Thanks for sticking with me here. Let's do one more to get this all taken away here. So solve the following system. We have x minus 3y plus 6z equals 21, 3x plus 2y minus 5z equals negative 30, and 2x minus 5y plus 2z equals negative 6. All right. So do you guys see any opposites here that would work nicely? We got x, 3x, and 2x, not really. Negative 3y, 2y, negative 5y, not really. 6x minus 5z, negative 2z, not really. No opposites that are going to work really nicely where we could cancel them pretty quickly, but I do see a 1x. Do you guys see a 1x anywhere? Yeah, we got 1x in the top here. So I'm going to use that top equation to cancel, to get the opposite of 3x and the opposite of 2x. Okay, multiply by a negative, which will make it really nice. So we're going to use the top equation as our frame of reference to cancel x's in both other equations. So let's write our equations here. We have x minus 3y plus 6z equals 21. And we have 3x plus 2y minus 5z equals negative 30. So what can I multiply the top equation by to get the opposite of 3x? Well, it's just 1x. I can multiply by negative 3 to get that to cancel. So when we multiply that, negative 3 times x is negative 3x. Negative 3 times negative 3y is positive 9y. Negative 3 times 6z is negative 18z. And negative 3 times 21 is going to be negative 63. Final equation is going to stay the same. Add straight down. X's are going to cancel. 9y plus 2y is 11y. Negative 18z minus 5z is negative 23z. Negative 63 minus 30 is negative 93. All right, we canceled the x's in the top equation. Now we got to use the top equation and the bottom equation to get the x's to cancel. So we have x minus 3y plus 6z equals 21. And we have in the bottom equation, we have 2x minus 5y plus 2z equals negative 6. Let me double check that. Looks good. So we're using the top equation to cancel the x's. What can I multiply the top by to get the opposite of 2x? I can multiply by negative 2 to get negative 2x. So top equation, everything multiplied by negative 2 is negative 2x plus 6y minus 12z. Negative 2 times 6 is z. And then negative 2 times 21 is negative 42. We have 2x minus 5y plus 2z equals negative 6. Add straight down. X's are going to cancel. 6y minus 5y is y. Negative 12z plus 2z is negative 10z equals negative 48. Now we have two equations with the x's canceled. Now we got to do elimination again to cancel either y or z. So let's write our top equations. Now we have 11y minus 23z equals negative 93. And we have y minus 10z equals negative 48. All right, now we need to do elimination again. We need to multiply to get opposites. What would be easier to cancel, the y's or the x or the z's, that is? Probably the y's, right? Because we have a 1y here, so I can multiply it by, the opposite of 11y is negative 11y, so I can multiply this bottom by negative 11 to cancel that. So rewrite the top equation the way it is, keep it the same. Bottom equation, negative 11 times everything is going to be negative 11y plus 110z equals, that's going to be 528. You multiply negative 11 times negative 48. Add straight down. Y's are going to cancel. We get 87z equals 435. Divide by 87. Z is going to be equal to 5. Z is equal to 5. What do we do next? Well, now we got to take that z equals 5. We got to plug into one of these other two equations to solve for y. So which one would be easier to plug into? I would say probably this one because it's got a 1y, which is really nice. So we got y minus 10z equals negative 48. We're going to plug in 5 for z. So we got y minus 10 times 5 equals negative 48. Y minus 50 equals negative 48. Add 50. Y is going to be equal to 2. All right. And now we got y and z. We still need to solve for what? What are we missing? We're missing x. So I'm going to plug into the top equation because it's got a 1x there, which is really nice. Plus 6. You don't have to divide by anything then at the end. All right. So we had x minus 3 times y, which was 2. Plus 6 times z, which was 5. Equals 21. 3 times 2 is negative 6. Plus 6 times 5 is 30. And negative 6 plus 30 is positive 24. Subtract 24 to solve for x. X is going to be equal to negative 3. So our final answer is going to be x, y, and z. So we have negative 3, 2, which is y, and 5, which is z. And there's our final answer. Look at all that color. So much work. All that color is to help us keep it organized a little bit. So, all right, thank you guys for watching. This is hard stuff, so make sure you ask questions in class if you have them. We'll go over extra problems. And have a great day, and we will talk soon.